Our final section in this review unit is chapter 1.6, where we look at multiplying and dividing real numbers, or numbers that have negative signs in them for our purposes. So the first one that we're going to talk about is what happens when you multiply numbers that have signs on them. And when the signs are the same, when you multiply a positive number times a positive number, you already know that you get a positive answer. Well, the same thing is true when you multiply a negative number times a negative number. That answer is also positive. When you multiply a positive number times a negative number, the answer is always negative. And it doesn't matter whether the negative number is the first one in the problem, or the second number in the problem, or whether the negative number is the bigger number or the smaller number. Anytime you have a negative times a positive, you're going to get a negative answer. I had a student several years ago who named these the Valentine rules. Let's see if I can get a somewhat sloppy heart around these. Because she said, as long as both of you feel the same about each other, that's a positive situation. You both like each other, neither one of you likes each other, it's all good. It's when you like somebody who doesn't like you back, or you don't like somebody who won't leave you alone, that's when things go wrong or get negative. So if that helps you remember the rules for multiplying real numbers, feel free to steal her idea. She said you could. Okay. So looking at this first example, the multiplication's not going to change. We'll still do multiplication just as we always have. A 4 times 3 is still going to be 12. And because our first number is negative and our second number is positive, our answer is going to be negative. Here we're multiplying a negative times a negative, so our answer is going to be positive. And to review real briefly how we multiply with fractions, we're sticking a 1 under there so that we have a numerator and denominator. We're looking for ways to reduce. So it ends up being 2 times 5 on the top, 1 times 1 on the bottom, which is 10 1/10, and we don't need the 1. So a negative times a negative becomes a positive. 2 times 5 is 10. 1 times 1 goes away. Positive 10 is our answer. This last example is the only place where things look a little different. It looks like we might, since the 0 doesn't have a sign, like we have a positive times a negative. But what happens when you multiply any number by 0? You get 0. And 0 cannot be negative. So anytime 0 is getting multiplied by a number, whether it's negative or positive, the answer is just going to be 0. Our second objective is talking about how exponents are affected by these negative signs. Okay. So looking at these, the rule I want you to remember is that order of operations, okay, that's the PEMDAS thing, still apply. Okay, so we need to take care of the exponent before the subtraction. Oops, before subtraction, unless the subtraction is in parentheses, or that negative sign. So when we look at this problem right here, the negative is grouped with the 9. So that means that the 9, the negative, is also getting squared. So if we rewrote this problem, we would have negative 9 times negative 9, and a negative times a negative is going to leave us with a positive 81. In this next problem, it looks really similar, but the squaring of the 9 needs to happen before we apply this negative sign. You could even think of it as having parentheses around the 9 and the squared. So the negative gets applied after we've squared the 9. 9 times 9 is 81. Then we apply the negative. So for this problem, the answer is negative 81 instead of positive 81. With this one, we have negative 3 times negative 3 times negative 3. Negative times a negative gives us a positive 9. That positive 9 times negative 3, we're back in the negative. This problem, if we were to stretch it out, the 3 is getting cubed all by itself, and then the negative is getting applied later. So 3 times 3 times 3 gives us 27. We put the negative sign on it. This answer also comes out to be negative 27. Okay? But that's because here there's 3 negative signs, which turns negative. Here there's only 1 negative sign. It just so happens to still be negative. And it's important to notice that difference because of situations where we're squaring. Because if all of these negative signs have somebody to partner up with, the final answer will be positive in this case and not in this case. Okay? We're going to look at 2 more special cases under this objective. Following order of operations in this problem, this is a little funky to read, but this says the fraction 2/3, it's negative, and then there's a 3 outside that 2. Okay? So looking at our order of operations again, the exponent is the first thing that we're going to take care of before subtraction or division or any of the other things. So this really reads negative 2 times 2 times 2 over 3, or negative 8/3. This problem here, the negative 2/3 in parentheses and then the cube, means that the whole fraction with its sign is getting multiplied by itself 3 times. So it's a negative 2/3 times another negative 2/3 times another negative 2/3 2 times 2 times 2 is 8, 3 times 3 is 9, times another 3 is 27, and a negative times a negative is a positive, times a final negative makes our final answer negative.